Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Stereoisomers of cyclic compounds arise from cis-trans relationships at stereocenters, and we must check for mesoforms, which reduce the count of distinct stereoisomers. Moving on to the next step. Identify the stereocenters. In 1,3-dichlorocyclohexane, C1 and C3 each bear 1 Cl and are stereocenters. Each has 4 different substituents when considering the ring connectivity. Moving on to the next step. Enumerate possible configurations. With 2 stereocenters, there are at most 2 is equal to 4 stereoisomers. These correspond to 1R, 3R, 1S, 3S, 1R, 3S, and 1S, 3R. And for the final step, check for mesoforms. The molecule has a plane of symmetry consideration, 1R, 3S and 1S, 3R, because C1 and C3 are related by the mirror plane passing through C2 and C5 of the ring. The 1R, 3S form is identical to the 1S, 3R form. This is the cis isomer, both Cl on same face, and it is a meso compound. It is superimposable on its mirror image. So, 1R, 3S and 1S, 3R count as only one compound, the cis mesoform. Count distinct stereoisomers. Cis 1,3 dichlorocyclohexane, 1R, 3S, 1S, 3R meso compound 1 stereoisomer. Trans 1,3 dichlorocyclohexane, 1R, 3R and 1S, 3S enantiomers, not superimposable to stereoisomers. Total is equal to 1, cis meso, plus 2 trans enantiomers is equal to 3 stereoisomers. Why other options fail? A. 0. Incorrect. Stereoisomers do exist. B. 1. Incorrect. This would ignore the trans enantiomeric pair. D. 4. Incorrect. This counts the meso pair as to separate compounds, which they are not. Therefore, the correct answer is C. Therefore, the correct answer is option C.